Hello, I want to get started. I want to welcome you to week one. I'm a little late with this meeting, so you're going to have to see it on YouTube. I apologize. It's my fault. I'm waiting to hear whether or not we have to have these Zoom meetings, but I wanted to talk to you tonight about curriculum conversations, the do's and don'ts on curriculum. Leaders are full of power. They share powerful ideas, make powerful decisions, and create powerful results. And initially, the power of leadership is inspiring, but after looking deeper, maybe not so much. We overlook how the exertion of power sometimes leaves others feeling powerless. Let me explain. I recently watched the classic film, 12 Angry Men, and the dialogue between the characters shows how power often yields powerlessness. In the movie, a juror is asked to explore his thoughts and join the conversation. In response, the juror stated, "I'm not used to supposing. I'm just a working man. My boss does the supporting." I share this quote because while teachers are thoughtful leaders, like bosses, we are told a lot of power. We hold a lot of power. As classroom teachers, we carefully design assignments. We tell the students what assignments are due, when we will assess, and ultimately how to jump through the district demanded curriculum hoops. As a result, students may come to view their role in curriculum decisions as unimportant or worse, non-existent. Sadly, students don't have the luxury of supposing and kicking around curriculum ideas. Remember, only the boss does the supporting. To be fair, there has to be some programs with this dilemma. First, we see the launch of student-centered curriculum research. Second, there are numerous books, blogs, and articles showing how to implement specific student-centered strategies. Lastly, there's the push to empower students throughout the learning process. Unfortunately, our students deserve more. One way to help them own their role in the curriculum, making the process, is for teachers to include them in the conversation. Here are 7 conversational do's and don'ts to consider when involving students in curriculum decisions. Do ask students if they know the difference between standards and curriculum. Spend time exercising how standards provide learning goals, while a curriculum establishes and identifies the steps to reach a learning goal. You can help students understand by using the Common Core standards as example of grade level standards, pulling out details to highlight common myths about the 2 concepts. Don't simply begin the conversation by asking who wants to help create curriculum. Provide a little context to help prevent misunderstanding right from the beginning. Do identify non-negotiable elements of the curriculum conversation. For instance, remind students that while learning goals are not debatable, their feedback is critical in designing how to reach these goals. Don't mislead students as to the extent of their influence on curriculum development. Do ask students to brainstorm political potential sources of and solutions for resistance to their increased role in making curriculum decisions. Talk openly about the doubts and fears that parents may voice. Address the positive pushback from school leaders like counselors and principals. Don't begin the student brainstorm session blindly. Consider ways to address common brainstorm pitfalls, like students conforming to the ideas of their peers or even mimicking one another. Do provide examples of how curriculum needs are different from curriculum wants. Emphasize that the goal is not to shrink the quantity of assignments, but to negotiate which assignments are most useful. Don't lead students to believe that contributing to curriculum decisions means that they will have sole power over every assignment, test, and project. Stress how their contribution will realistically impact the curriculum. Do encourage students to reflect on how time affects curriculum decisions. For instance, ask for feedback on, would working independently or with partners be the best for the assignment? The way that we're going now is working together with partners. We're going to alternative assessments. I know that when I taught last year, we basically were told that we would need to have the kids working in groups, not working only with each other. And when the administrators did their walkthroughs, they were looking for us having kids working together, and we were marked down if the kids weren't working together. How will granting time for project work subtract time from other assignments? I know that we like to teach to the test because our evaluations depend upon it. How can we determine the appropriate time to dedicate to assignments? What happens when too much or too little time is estimated for assignments? Don't wait until the students have designed a cool assignment to saddle them with the bad news that there just isn't enough time to complete it. Do explore ways of building upon current curricular assignments to introduce new learning opportunities. For instance, as suggested on the Learning Scientist, blog upgrade, how flashcards are used as a review tool, maybe devise a plan to never assign the dreaded 5-paragraph essay again. Try a new take on vocabulary practice with quick word graded activities, and you can find that on the internet. Even challenge students to develop their own revisions of traditional assignments. So you can have kids involved in developing curriculum with you. Don't neglect to model examples of ways that students may modify current assignments. Do acknowledge that students may react differently to the responsibility of participating in curriculum decisions. To build confidence in their choice, communicate that it is safe for them to jump in quickly or ask for more information. Allow the students to opt out of the process if they ask. Don't force choices upon students when they are uncomfortable with participating in curriculum conversation. This may result in a power struggle, and the student will resist contributing useful ideas. With this alternative assessment, we need to give kids more choices. Like I would say to my students, I wanted them to do a project on a particular broad topic, and they could pick the topic that they wanted to do the project on. They could also pick how they wanted to present the project. Did they want to present the project as a PowerPoint, a Prezi, or as a video, or did they want to use note cards and poster boards? Most of the kids did not use note cards and poster boards. That's kind of the old way. Most kids use PowerPoints or Prezis, and then I had some kids who did some really good videos. So you can have kids involved in curriculum, which is really important, because once you can get buy-in by the students, it is better for them to finish the projects and do a good job on them. Project-based learning research review. Studies have proven that when implemented well, project-based learning can increase retention of content and improve students' attitudes toward learning, among other benefits. Research review explores the vast body of research on the topic and helps make sense of the results. In the series of 5 articles, learn how researchers define project-based learning, review some of the possible learning outcomes, get recommendations of evidence-based components for successful project-based learning, learn about best practices across disciplines, find tips for avoiding pitfalls when implementing BL programs, that's project-based learning, and dig into a comprehensive annotated by bibliography with links to all the studies and reports cited in this page. What is project-based learning? Project-based learning is like what I said, what we're going to. With the kids actually, you no longer being the sage on the stage, and the kids being the, you are the facilitator of information, and the kids are basically the ones who are creating. As I've taught a lot of these classes online, I see teachers engaging in some very creative ideas with their students. A lot of group work activities could be project-based learning. Like I mentioned before, having the students decide how they want to present. Do they want to work with partners? Occasionally, I've had a student who wants to work alone, and I will never force a student to work with a partner if he or she does not want to. Project-based learning hails from a tradition of pedagogy which asserts that students learn best by experience and solving real-world problems. According to researchers, project-based learning essentially involves the following: students learning knowledge to tackle realistic problems as they would be solved in the real world. Increase student control over his or her learning. Teachers serving as coaches or facilitators of inquiry and reflection in students working in peers or groups. Doesn't have to be all the time. They can do a project on their own, but the push is to get them to work together. Like I said, our administrators would come in our classroom and they would be looking for kids working together on projects, and me going around to all the groups and helping to facilitate them. When we got our walkthroughs back, if we had the kids working on things that were alone, we got marked down. Inquiry-based teaching methods engage students in creating, questioning, and revising knowledge while developing their skills in critical thinking, collaboration, communication, reasoning, synthesis, and resilience. Although these methods of inquiry-based teaching differ slightly, for simply, they're centered on these pages and referred to as project-based learning, or PBL, learning outcomes. Studies comparing learning outcomes for students taught by project-based learning versus traditional instruction show that when implemented well, project-based learning increases long-term retention of content. When I think back on all the classes that I've taken, and all the information that I've studied, and the classes, the tests that I've passed, I don't remember a lot of that information that I don't use. But I do remember the projects that I worked on. And when I was in graduate school, I worked more on projects than I did in undergraduate school, especially in my education classes. And I remember those projects and how we worked on them. I remember my dissertation. My dissertation could be considered a project, something I worked on for a long time, 2 years, and I'm quite familiar with it. Okay, project-based learning improves problem-solving and collaboration skills. It can provide an effective model for whole school reform. 2016, Lucas Education Research Literature Review found that design principles most commonly used in project-based learning align well with the goals of preparing students for deeper learning, higher level thinking skills, and interpersonal skills. I really loved watching my students work together. I love the interaction they had. I love just watching them decide. I would give them a piece of paper and it would have 10 issues that were important in our government, because I taught government class. And I asked them to get in a group and to come up with the ones that the group thought were the top 4, and to explain to us why the group decided that they were the top 4. At first, I had the kids number them on their own, and then I had the kids decide in a group which ones were the best. And they did make a decision. They did come to a consensus, and it was interesting watching them. Researchers have identified several components that are critical to success. While project-based learning has been criticized in the past for not being rigorous enough, the following features will greatly improve the chances of a project success. A realistic problem or project. Like I said, I gave them issues that were relevant to today's government or today's issues that we were dealing with, like pollution and other important issues, and they had to decide which ones were the most important. A realistic problem or project aligns with students' skills and interests, requires learning to be clearly defined in content and skills, in structured group work. And kids like working together. Even adults, we're getting to the point now that when we go to faculty meetings, they're having us work together instead of just dispensing information to us. Groups of 3 to 4 students with diverse skill levels and independent roles. What I would do is if I had an ELL student who didn't speak English very well, I would pair him with an ELL student who spoke English really well so that he could explain the project to him and the child could be on board. And I like to mix it up. I like to mix it up with a student, with an ESE student, put an ESE student in a group where a student wasn't an ESE student, so that the student who wasn't an ESE student could help the ESE student. Multifaceted assessment. Multiple opportunities for students to receive feedback and revise their work. Multiple learning outcomes, problem solving, content, collaboration. Presentations that encourage participation and signal social values, exhibitions, portfolios, performances, reports. I would have my kids do skits. and they like to do skits. They used to like to play out in psychology. I used to also have them do experiments where we would have a group of 3 or 4, and I had this book on psychology experiments, and they would come in and they would have prepared and they would have brought all the materials necessary, and we would conduct little psychological experiments in the classroom. And so you can find a lot on the internet now on project-based assessments, and probably you're doing them at your school right now. You may be involved in this. Okay, I wanted to talk a little bit about STEM. And STEM is a big word, and it's talking about science connected with technology. There is no universally agreed upon definition of STEM. Experts generally do agree, however, that STEM workers use their knowledge of science, technology, engineering, or math to try to understand how the world works and to solve problems. Their work often involves the use of computers and other tools. STEM occupations are identified in a variety of ways. And this article that I'm talking about uses a list based on the Standard Occupational Classification Manual to annualize occupations from 6 groups, including computer and mathematics, architecture and engineering. Healthcare occupations are excluded from this analysis because they are described in a separate article. STEM fields are closely related and build on each other. For example, math provides the foundation for physics, and physics, in turn, for engineering. Engineering can apply their knowledge of physics to make high-tech devices that are useful for testing theories in physics. Advances in physics may then lead to advances in engineering and technology. Science workers study the physical and rational world through observation and experimentation. Science is a lens to interpret the world. Science workers can also inform public policy, such as by providing data to support limits on the use of toxic chemicals. The work of scientists often involves research, writing proposals and academic papers, and presenting findings. Science technicians collect samples, conduct experiments, and do other tasks to assist scientists in those efforts. Workers rely on the scientific method to objectively test hypotheses and theories. The scientific method requires reputable experiments that produce predictable and observable data. When the data matches the theory's predictions, the experiment supports that theory. Theories with most support evidence are adapted, but many continue to evolve based on new evidence. Disciplines in science are characterized based on the part of the universe that they study: space sciences, earth sciences, life sciences, chemistry, and physics. For example, the life sciences study the living world, such as plants or the human body. Disciplines include ecology, genetics, neuroscience, pathology, and nutrition. And here are just a few STEM occupations. This is really a big thing now to get schools involved in having a STEM part of their school. Computer and information research scientists, computer network architects, computer programmers. In architect and engineering, we have aerospace engineers, agricultural engineers, biomedical engineers. In life and physical and social scientists, we have animal scientists, astronauts, atmospheric and space scientists, geological and petroleum technicians. In education, training, and library, we have biological science teachers, post-secondary, chemistry teachers, post-secondary, computer science teachers, post-secondary, engineering teachers, post-secondary, and faculty, forestry and conservation science teachers, and post-secondary. So those are just a few. Technology. Technology workers use science and engineering to create and troubleshoot computer and information systems. For example, some tech workers develop software applications and build and maintain computer networks and databases. Technology work connects people, making all forms of communication, including business transactions, video sharing, and mobile browsing, faster and less expensive. The work often involves designing, testing, maintaining, and improving computer software, hardware, systems, and networks. The goal is not only to solve problems, but also to make that problem easier to solve in the future. STEM technology refers to disciplines in computer and information sciences, including those related to operating systems, artificial intelligence, programming, cryptography, and mobile computing. And we're going to have jobs in these fields. That's why they're pushing the STEM field, is because there will be jobs. Engineers and engineering technicians use math, science, and technology to solve real-world problems. The work often involves developing systems, structures, products, or materials. A civil engineer might design a new train station to accommodate more passengers, and an environmental engineering technician might help create an environmental remediation device. Engineering makes things better and cheaper for everyone. Without it, we couldn't live in this kind of society we know, with bridges, clean water, and cars. Disciplines in engineering are often categorized by industry, such as aerospace, petroleum, or textiles. Major disciplines include civil, mechanical, industrial, electrical, and materials engineering. Math workers use mathematical, spatial, and logical relationships to study and solve problems. An operations reward analyst helps organizations identify practices that improve efficiency, and a mathematical technician applies standard formulas to technological problems in engineering and physical scientists. Mathematics is a technical foundation for science, engineering, and technology. The work often involves finding patterns in data or abstract logic. These patterns can be used to draw general conclusions about data, to test mathematical relationships, and to model the real world. Disciplines in math include algebra, statistics, calculus, game theory, and geometry. Overall, STEM occupations are projected to grow faster than the average for all occupations. And wages in these occupations were generally higher than the median for all occupations. So we're going to talk a little bit about STEM and the occupations. STEM employment, as defined, is to grow about 13% between 2012 and 2022. This is faster than the 11% rate of growth projected for all occupations over the decade. But projected employment growth varies by occupation. Knowing which occupations are projected to have the most job openings and fastest growth may help you narrow your career options. So, job openings. Computer systems analysis, 209,000. Computer user support specialist, 196,000. And this is projected openings in 2012 to 2022. Software designers, system software, 134,000. Computer programs, 118,000. Network and computer systems administrators, 100,000. Mechanical engineers, 97,000. Industrial engineers, 75,000. And web developers, 50,000. Electrical engineers, 44,000. And computer network architects, 43,000. And those are job openings projected. And then the typical degrees that you need are just a bachelor's degree or an associate's degree for a web developer. My son works in computers, and what he did is he has a degree in linguistics, but he went and he took all the Microsoft computer classes, and now he is a computer architect. And he's making probably $135,000 a year. He's a boss. But these jobs are going to become available in the future, and that's why we want to get STEM involved. Nearly all STEM occupations discussed are projected to grow between 2012 and 2022, according to BLS. And many STEM occupations are projected to grow faster than the average for all occupations. Some of these occupations are in technology, others are related to math and engineering. between 2012 and 2022. There is a projection that the fastest growing occupations to have many job openings relative to their employment size, but that doesn't necessarily mean that these occupations have high employment. Some occupations, such as biomedical engineers and mathematicians, have small employment levels and are projected to remain small despite fast growth. Occupations with both high employment and fast growth usually offer better opportunities than small occupations in small and slow growth. High employment, fast growth occupations include computer systems analysis, application software developers, and systems software developers. And I told you about the wages. A lot of times the wages, the median annual wage is $76,000, more than double the $35,000 median wage for all workers. Teachers usually start out at about 35. And if they have a master's degree, they can get up to about 37.5. But teachers don't make a lot of money, as you well know. I know in some states, though, if you stay in the occupation long enough, you can make $75,000 to $80,000 a year. Not in the state of Florida. The state of Florida, well, my district caps off at about $65,000, and it takes you a long time to get to that level. Like that of most jobs, in both rewarding and challenging, you might work on an interesting project that yields meaningful results. But to complete many times or navigate complex governmental regulations. Many STEM workers find their jobs intellectually stimulating. They enjoy collaborating with people who share their enthusiasm and working with cutting-edge technology. STEM offers a cooperative, innovative, and exciting work environment that is unparalleled. Depending on the occupation, STEM work may be creative and produce tangible results. Biologists might make a discovery in the laboratory and publish that research in a scientific journal. The civil engineer, technician may help design a storage facility or other structure and then assist in working with the contractor who builds it. Workers in STEM occupations also enjoy the variety of problems they solve. Every problem is a unique challenge to figure out. Even if you use similar skill, the way you apply it is different. Because many STEM fields involve rapid change, workers' professional development is also dynamic. There's always something more to learn. Don't expect an end. So STEM jobs are basically going to be available, and that's why we need to push our kids in math and science so that they can get these high-paying jobs that are creative and interesting. I know in our school, we had we were a magnet school for a period of time where we had clusters, and we had the technology cluster, and we also had the graphic art cluster. And with the technology cluster, our kids could graduate with a certificate. If they could pass the tests, they could graduate with a certificate in computers. So we're seeing more schools that are implementing computer-based classes. And I'm going to stop here, and I'll probably finish this next week on STEM, and we'll do something else. And if you have any questions, please ask, and email me or call me, and I would be more than happy to help you.